Okay guys, it's coding time. Let's recall the subtasks that we're going to code. Subtask number 1, determine the points of each valley. Subtask number 2, find the intersection point between the lines and the line of ferries to find all segments. And subtask number 3, find the minimum number of points covering a set of segments. Okay. Let's write here is some comments. Subtask 1. Determine value points. As we have seen in the subtask, we're going to use this convex hull, the upper convex hull. We don't need here the lower convex hull. We don't need this. We need, for each valley, we need the upper convex hull, like this, for each valley, like this, etc. We have seen this. Okay. So we need a function here for the convex hull. Before that, let's create a type point here instead to use pair and each time. Let's double here. We're gonna, because for the segments with not integers, are not integers, the segments, they're double, they're real. Okay, let's call it point. The function convex hull here, we're going to run over all the points here from left to right to get these points for each valley, and then from right to left to get these points for each valley too. This, etc. Okay. Let's read the input here. We have to first the size of the number of points and the line of ferries here. I call it YF. Are we going to read all the points now? Points, we'll declare this later. Points is equal sorry this I prefer here to use a vector of point sorry okay. For subtask number 1 we have to get all the points on the left side for all the values. As you see here, it's a pair of points for each value. So here we have a pair point 1 and point 2 for each value. Let's call it values points left side. It's a long name, but it's okay to understand what we do here. We're going to call the function convex hull. We're going to implement this later. Convex hull, it takes all the points, the size n, and k, because we have two directions here, once from the left and then from the left to right and then from right to left. We're going to add another parameter here, which let's call it the dir or direction or whatever. This direction, if direction is equal to 1, for example, choose what you want to choose, it true or false or another thing. Direction is equal to 1, we're gonna run from left to right. If direction is equal to -1, for example, we're gonna run from right to left. So here we have 1 for the left side, then for the right side let's put here -1, but as you see here for the right side we're gonna start from the table from the right. As you see here, all the points are already sorted. We don't have to sort here the array. Sorry for this. And then from right to left, we're going to read or run from the end until the first one. So we have to reverse. We have to reverse the array here, the array of points. Reverse. Okay. convex hull function I'm going to return a vector of pair of points, vector of pairs here, points, and take a vector that contains a points and the size, and the direction here. As I said, we don't need to sort, the array is already sorted, as you see. So upper hole here. So I'm gonna run over all the points. While, as we have seen, how to compute the convex hull. Let's start from the left to right. From left to right. The direction or the orientation of this point with respect of these 2 points must be positive to add it to the convex hull. If it is negative, we have to delete this point until we find a cross product positive, as we have seen in the previous parts. First at all, the upper hull must contain at least 2 points. Cross product, we need the function cross product here. We're going to implement this later too. Okay. As we have seen this a pointer, we have to put stop here. Okay. And the point B, if the cross product is negative, this from left to right is negative, so we delete the last point from the upper. If it's okay, then add it to the upper hole. Okay. But here we don't need all the points here, just these 2 points for each value. How to tell the function convex hull that we need all these points? As you see, it will start from here and here, 0, sorry, this is 2, not 1, this is point 0, point 1, point 2, point 3, point 4. As you see, how to know it's a value or not? It could be divided by 2. So here we need a counter, not for each loop here. And then we don't need to start from the point 0, we start from here and we reach this point when we don't need this and this. So n minus 1 here, plus I, okay, then point B is equal points of at index I, is the current point, so here we need another array here to store the values points. It's equal to okay. We tell to the function here if the current point, if we reach a value, then add to the value points the two last points of the upper hole here. We need this, okay. And we return this. We need the function before the function cross product. This is from right to left, left to right. Sorry, left to right. How to compute now the points from right to left? You can do another function. We can use the parameter direction here. For this particular case, direction must be 1 or minus 1. Why? If we multiply this by 1, the sign is going to change here. As we have seen, from left to right, the upper hole, to add a point to the upper hole, the cross product of a point with respect to the last points of the upper hole must be positive. What now from right to left? This is the upper hole. This is the point what you want to add. As you see, with respect of this 2 points, as you see, counterclockwise, which means the cross product must be negative. So when the cross product is positive here, we delete this point. So here we can multiply by minus 1. This direction, it will be 1 if we want it from left to right, minus 1 from right to left. So we'll multiply this by the direction here, this one here, as point. Okay, the cross product function it will take as parameter a point A, point B, and the point, let's call it P as we have called it in the convex hull. We need the x and y coordinates for each point. It's double, I think. It's good because this is okay. Let's compute the cross product. Cross product, we want to compute P with respect of A, B. P with respect of A, B. So it will be, okay, where is the cross product? Okay, let's do it another time. Is point A, point B, A, P. P, B, P, B times P, A, which is the components of P, B, it's X, B minus X, P, Y, B minus Y, P. The components of PA, it's XA minus XP, YA minus YP. The cross product is XB minus XB, is XB minus XP, XB minus XP times YA YP minus XA minus XP times YP YB YP YB YP YP. Okay, to return the cross product. Let's check if we have done all things right here before we continue. We have to display, I'm going to display all the points for each value. This is the first point, this is the second point, let's call it B. Second point. Now let's display the point, the XY coordinates, which point. This is the points of value from left to right, then from right to left. Just here. Let's try it for this example. Here. Line 25. Here, vectors. Okay. One here. Let's do it more here. It's better. I think here we have a conversion problem. And convex. Here we have made a mistake here. Okay, the vector of points for the upper. You have to add by point by point here to the upper hole. And I think that's the mistake. Voila. Again. here now. If I value points, push back. I forget the function push back to push the pair and the value points. Voila. Vectors. Voila, an error. He's sorry for this, guys, but it happens sometimes. Okay, let's see if the points are correct here. For the left side, we have minus 2, 0, minus 1, minus 2. We have 0, 0, 1, minus 5, 2, 8, 3, 0, 2, 8, 3, 0, 2, 8, 5, 1, 2, 8, 5, 1, 2, 8, 7, 1, 2, 8, 7, 1. This is the left side. The right side, 8, 8, 7, 1, 8, 8, 7, 1, 8, 8, 5, 1. This 4, 2, 3, 0. Okay, 2, 8, 1, minus 5, 2, 8, 1, 2, 8, minus 1, minus 2. Okay, it's correct. So we can delete this and continue. This is subtask number 1. Subtask number 2. Get all the segments. Get all the segments of each value, of all values here. Okay. For each segment we have 2 points, left point or right point. So it's a pair of points 2. Let's call it segments is equal. Let's implement a function. Let's call it get segments. It will take as parameters, I think this 2, 1 is obvious. This 2 and this one. Okay, for the moment I think it's only this one. We're going to see later what happened. Let's implement this function. Let's implement this function here. Okay, how to do this? We have to compute. Let's start with the left point of the segment. The left point of the segment, it will be the 2 points are in this array. I think we have to run over this array and the other one. Let's is equal one of these arrays of this one size. Let's store it in a variable here, and we have to loop into this arrays. How to find the x left point, the x coordinate of the left point of the segment? By computing the intersection. So let's do this. Let's call it x left is equal. We need another function here. Compute intersection. It will take this one, okay, the 2 points, the 2 current points, and the line of varies here. Okay, we have to add to the parameter here. And also here. For the xy point, same thing. XY point of the segment here, but we're gonna use this array which contains the points from the right to the left. So here, the first point, the first 2 points, as you see here, this is value number 1, this one, but in the second array is here at the last index here, last one. How to reach this? How to get this and this? How to get the left 2 points? By just call it by its index here, I, but here it's not I, is not the size, is the size of the value minus I minus 1. Here, for example, the size of the array is 1, 2, 3, 4, 5 minus at index 0, so it be 0. 5 minus 0 is 5, but here it is at index 4, so we have to add minus 1 here. So this is our I. So here it will be MB. Of course, you can figure out another way to access this element. MB values, this one, minus I minus 1. Okay. We need an array to store all the segments. Okay, store each segment, it's 2 points, x left and x right, and this function will return the list of segments. Okay, let's implement now this function. Compute intersection. It will take a pair of points let's call it to AB, let's call it AB, and the line of varies, I think. Okay, let's call it Y. It's a double, I think. no, it's long. Okay. Let's get the first point from this is the pair AB. Point AB, it's AB is AB dot first. Point B is AB dot the second one, the second point. Now we need the x and y coordinates of these 2 points. Okay. Same here, I think. This is for A, and this is for B. As we have seen in the task number 2, this general formula, we have to compute the slope of the line, this line made of the 2 points AB, which is the line of the left side of the valley here. And the constant B, we have done this in the previous parts. Okay, subtask number 2. A is equal YA minus YB. Double A is equal, let's make it simple. If XA minus IB, XA minus XB is equal to 0, okay, so yeah, let's do this, is better. Double A is equal what? Is equal to 0. If XA minus IXB is equal to 0, otherwise we have this formula here. If XA minus XB, XA minus XB is different 0, then A is equal to YA minus YB over XA minus XB. YA YB XA XB. Okay, now B is equal YA minus is equal YA minus A times XA. Okay, let's compute the X here. In general, X is equal to this. Double X is equal to YF minus B. If A is equal to 0, otherwise is equal if A is different 0, then X is equal to YF minus B over A, and return X. Okay, let's check it if it gives us where is the points here, these points for this example here, this example. Okay, example, here we have a pair of points, so for each pair we have to display the first point, which is the x left of the segment, the left point of the segment, and the right point of the segment here. Okay, let's try it. I hope there's no compilation error. There is. Voila. Okay, I think there's this one. Okay. Complicated. Okay. This one. Oh, where exactly? Computer intersection. Point A, double A. Let's call it here. Slope. Slope. Okay. And here will be slope. And here, and here, and here. Okay, I think it's okay. Slope is equal to 0. Double F is okay. Slope. Slope. Okay. Come on. B2. Sorry for this. Oh la la la. B is same thing here. Let's call it. Let's call it constant B. CB. We have to add. Okay. Not this one. This one. Constant. Okay. Constant B. Okay, here constant B. And here constant B. I think it's okay. YF is not declared. Yes, it's Y. Constant BB here. There. Okay, now here. Pair point segment. segment, but push back. What's wrong here? No matching function for call to push back. Push. Yeah, it's correct. Push back. That's not a point. It's not a pair of points, sorry. Here. A pair of double here, because we have only the x coordinate of each segment. I hope this is the last error. No, it's not the last. You can skip this part, guys. It's very boring. Return segments. Okay, double. Here too. No. Oof. Finally, we have an answer. I hope it's correct. Okay, minus 6.523 minus 18775. I think it's correct. 15284 15124. What exactly? 1281. 1281. X correct. Okay. Now subtask number 3. We have to compute the minimum number of intersections of this set of segments. Minimum number of intersections of the computed set of segments. Okay, okay. This is our final answer here. This is our answer. We have to implement a function. Let's call it minimum number of fairies. This is our final answer. Fairies it will take the set of segments here, then we're gonna output our answer. Okay, like this. Let's implement this function, guys. This is the last one. let's compute the side of the segment. Let's call it n segments dot size. Okay. As we have seen in the where is it? I think I lost it here. Okay, here. We analyzed this in subtask number 3 on the previous spots. Please check it if you forgot how to compute the minimum number of points covering a set of segments. First, our answer, we're gonna say that our first segment is our answer. So we have one segment here, one part, and we have to compute before all these things. We have to sort the list of segments as we have seen here. The list must be sorted. The list of segments must be sorted here. So we're going to sort the list of segments by the second point, not by the first point, by the second point. I have to use, we can use the normal function here, it's a callback function, or use directly anonymous function was called as a k lambda function here. We have 2 points here, point P1 as parameters, point P2. This function is gonna return if P1, the second point, gonna work. It's called callback function. It's gonna work. The sorting is gonna work if P1 is less than the second point, the second element of the point of the segment is lower than the first one. Okay, I think that's all right. Let's continue here. Let's take the second point of the first segment. Let's call it P, whatever. Okay. Then we run over the rest of segments. Until the final end. Okay. And as we have seen, we compare the second by the first. If it's greater, nothing happens. If it's lower, like this here, then we add answer. We have to add another part. Answer becomes +1. We add 1 to the answer, and the segment, the current segment, will be this one. If segments of I dot the first element of the segment is first element of the segment if P here this one, this first, the element of the current the second element of the current segment is lower than the first element of the next segment. Then we have to add another part and update P here, which is become the second element of the current segment. At the end of this loop, we have to return the answer. Let's check. Let's delete this one. Okay, here we have an error here. What's happened? I think sort again. We have okay. Yeah, this test is passed. That's one of all these tests. Try it. Okay, all these tests are passed. Let's try it, or let's submit it on the online judge, like Demage here. Okay, it's French plus English. Submit the solution. Of course, I have tried this before. Okay, let's submit it. We have one answer here. What happened? Maybe here as PB times PA. PB times PA, which is XB minus XP times YA minus YP. YP here, not YB. Okay. And XA minus XP, YP. Let's submit here, and here we have YB. Okay, let's submit again. Okay, here is accepted. You can submit your solution too on the evaluator of this website here. I think this website contains all the I have it here in mine. This one. This website contains all the Croatian Open competition in informatics, all the previous contests here. It has an evaluator. It's here. You will find this in the description on the videos. Let's submit this file. Okay, planine CCP. Choose the file. this one, this language C++. Okay, let's try it here. I have submitted this before, as you see. Okay, it accepted, it passed the test. Sorry guys, this video is a little bit long because I have many compilation error. It's my bad, sorry guys. I hope this series of videos is helpful for you. See you in the next problem here. Thank you guys.